Hello and welcome to EduSathi's lecture on coding decoding. Now, there is no concept as such in this lecture, but we'll cover different type of questions that are asked in the examination. It is more of an IQ based topic. Now, what is coding decoding? The method of transmitting a message from one to another and vice versa. Let's begin. So, concept 1 here is letter or number coding. Here, letters of a word are replaced by certain other letters or numbers according to a specific rule. For example, if teachers is coded as VCCA JCTQ, then children would be coded as what? Now you have to decipher how did the examiner write teachers as this. Let's look at it. I have a letter T here and a letter V here. I know that according to the alphabets, I have T, I have a U, and then I have a V. So there might be a case that the examiner missed out this T, this U here, and straight away skipped from T to V. We'll have to validate this assumption of ours. Let's look at the second letter. Now we have E, F, and G. But here instead of G we are having a C. So this logic does not hold true for the second letter. Then we look at what the second letter here actually says. It is a C. So we know that if I have C, we have a D and E. So it means that the first letter is going forward by one letter and the second letter here is going in the reverse direction and skipping out an alphabet. So instead of T, we have replaced it with V, and instead of the second letter E here, we have replaced it with C. Let's look at the third. I have A and here I have C. So again, I have A, B and C. The examiner skips out the B and straight away moves from A to C. So now what the coding done here is, if the letter is at the odd places like 1, 2, 3 or 5, then the alphabet is replaced by the alphabet leaving one in the forward direction. So for example, T would be replaced by V. I'll skip out U. If the alphabet is in the even position, for example E here, the second position, then I'll go in the reverse direction. In this direction, skip up a letter, I'll skip D and then write a C. So I'll skip in one letter in the opposite direction. So let's see for this what would be the code for children. So C is the first letter, so instead of C I'll skip out D and I'll write E here. So C would be replaced by E. H is the second letter in the even place. So I'll have an F for H because I have F, G and H. I have to move in the reverse direction, skipping out a letter. So this skips and I have EF. Now if you look at the answer options, I don't need to go further because I had only two options starting with E and there is only one option in which the second letter is F. So without checking the rest of these alphabets here, I can straight away mark my correct option is B. So these kind of simple questions are asked. You just need to find the logic and the answer would be in front of you in just a matter of seconds. Let's try another question. If transfer is coded as this here, then elephant would be coded as what? Now what I can make out just by looking is that this is nothing but a rearrangement of these letters. I have all the letters of transfer and rearranged. So I need to find out how are they rearranged. Let's look at it. I have TR here and RT here. So there's a possibility that I'm just reversing in pairs of 2. But we'll have to check further. I have AN here and NA here. My assumption is good. Then I have SF here and FS here. So again it's good. And then ER and RE. Make sure you go till the end. The logic should be valid through and through. So how would elephant be coded? The first two letters, I'll just reverse them. I'll write LE, then EP would be replaced by PE, then HA would be replaced by AH, and NT would be replaced by TN. So let's look which answer option is correct. I have LE, PE, HA. No, this one is not correct. Then I have LE, PE, AH, and TN. So this is the right option. Let's look at another example. If prepare is coded as this, then reasoning would be coded as what? Now the first thing that comes to my mind is that when I move from prepare to its code, the number of alphabets are getting reduced. So there must be some sequence, some logic as to how these number of alphabets are getting reduced. Let's check. I have P here and I have P here. So till now I'm good. The second letter here is R, but I do not have an R here. So I'll just cancel out this R. Then I have E and E comes here. Then again I have P. There is no P here. So I'll cancel out this P. I have A and I've got an A here. Then I'll cancel out R and I have an E here. So what the examiner is doing is he's coding by leaving out the alternate alphabets. So how would reasoning be coded as? I will take R and I will cancel out E. Then I'll take A and I'll cancel out S. Then I'll take O and I'll cancel out this N here. Then I'll take I and again cancel out this N, and then I write G. So is there an answer option satisfy this logic? Yes, the answer option is B. Example 4. In a certain language, cow is coded as 031523. Then the code for horse is what? Now, the first thing I look at is that I have 3 alphabets here and 6 numbers here. The first thing that should come to your mind when alphabets are being changed into numbers is this principle of Ijoti. Now, Ijoti means that E is the 5th alphabet in the English alphabet series. J is the 10th letter. O is the 15th letter. T is the 20th letter, and Y is the 25th letter. In all, we have 26 alphabets or letters. So this makes it a little easier. Now if C is easier to find out, we have A, B and C. So C is the 3rd letter, so that is why I have a 03 here. Now O, as by the Ijoti principle, O is 15. So I have 15 for O, and W. Now I don't know what is W, but I know that Y is 25 and W is 2 places to the left of Y. So I have W, X and Y. Then I have Z. So if this is 25, then X is 24 and W is 23. So the code for W is 23. So what the examiner is doing is he is replacing these alphabets by their relative position in the English alphabet series. Now how does this Ijoti principle help you? If you have to find out the number of any letter in the series, you will find out the nearest letter, like is it closer to J or O, and then you can subsequently find out. Like I had to find for W, I know W is near Y, and in a second I was able to find out that the position of W is 23. So let's look for horse. One thing I know is that by the Ijoti principle, O is 15. So the second number here should be 15. I just have 15 here and I have 15 here. 88 cannot be the case because we just have 26 alphabets. So by logic this has to be the correct one, but we'll still check. H is the 8th letter. I have E, F, G and H. So if E is 5, F is 6, G is 7 and H is 8. So I have an 8 here. I cannot write 8 like this. Why? Because when C was written, it was written as 0 and 3. So that is why H would be written as 0 and 8. So what is my correct answer option here? The answer option B. If apple is coded as 4, orange is coded as 6, then how is guava coded as? Now, the first thing that comes to my mind is orange has 6 alphabets, so that is why it is coded as 6. But apple has 5. Why is it coded as 4? The answer is P is repeated twice. So how the examiner has coded this? He has coded by taking this number as the number of unique letters in the word apple. So unique letters or alphabets are A, P, L and D. So that is why this 4. In orange I have 6 unique alphabets. So that is why this 6. In guava, how many unique alphabets do I have? I have a G, I have a U, I have a A and I have a V. This A is a repetition. So how would guava be coded as? Again 4. So what is my right option here? The first part. If exam is coded as 43, then the code for result would be, now whenever you see a number greater than 26 here, then it means that they have done nothing but just added the number corresponding to these letters. For example, E is 5, X is 24, like mentioned here, A is 1 and M is 13. When you add all these, you'll get the number as 43. So remember the Ejoti principle. E is 5, this is 10, this is 15, this is 20 and this is 25. It will be easier for you to write for the answer option. So for example, I have R here. If I know that T is 20 and I know that R, S and T come together, so if T was 20, this is 90 and this is 18, so I'll straight away write 18 here. Ejoti, E simply 5, T comes in Ejoti simply 20. So it makes this calculation very quick and convenient. So what the answer is, we'll just add up these numbers here. I have these two combined to 40, this is 60, 72, 72 plus 18 is 90, plus 5 is 95. So this is the correct option here. Let's look at this another question. In a certain language, TDP is coded as GWK and INC is coded as RMX. Then what is the code for SJP? Now at the first look I don't understand any logic. I have a T here and then I have a G. No logic perhaps. But what is the right method here? Again I'll write Ejoti. Now T is the 20th letter or it is the 6th letter from the behind. Similarly, G, if I write down, I have E, F and G, is the 7th letter from the front. So T, sorry, is not the 6th letter but the 7th letter from the behind. I have U, V, W, X, Y and Z. So after T I have 6 letters. So it makes T the 7th letter from the behind. Similarly, G, before G I have 6 letters. These 6 letters. So G is again the 7th letter. In other words, if I add the number T plus G, I'll get 20 plus 7, which is 27. Similarly, D plus W. So D plus W would be, D is the 4th letter and W, as we calculated in the previous question, is the 23rd letter. So 4 plus 23 again is 27. Similarly, when you calculate for P and K, the sum will come out to be 27. In other words, the logic is, if T is 7th from the behind, then it is replaced by G, which is 7th from the front. So we have to calculate for SJP, S, J and P. Let's see what will replace S. S is the 19th letter. So 19 plus X is equal to 27. This gives me X as 8. Now what is the 8th letter from the front? 5th is E, G is 7th, F is 6th, so H is the 8th letter. So I know that S would be replaced by H. So I can either have this option as the right option or this one or this one. Let's look at J. From Ejoti principle, J is simply clearly 10 plus here X is equal to 27. This gives X as 17. I know that O is 15 by the Ejoti principle. So P is 16 and Q is 17. So J here would be replaced by Q. So I look, my code becomes H, Q and something. In the second place I have a K here, I have a K here, both of them cancel out. So my correct option is the B part here. I don't need to go further and check. Also because P had K here, so this P will also have a K. Let's move on to the second concept, which is symbol coding. What happens here is that words, numbers or letters are represented in some symbolic language in a jumbled array. For example, in a certain code, rain is written as this, more is written like this. Then what is the code for remain? How do you solve these kind of questions? I will see R comes here first. I don't know which of these symbols is used for R. It is not important that 8 is the symbol. It might be that 6 is a symbol. So what I do is I find R in this other word. It is at the third place. Now if the first place here and the third place here match, which they do in this case, it means that R is coded as 8. Now life is simple for me. Now I simply know that the second word here, A, is coded as a dollar sign, I is coded as a percentage sign, and N is coded as a 6. Similarly, M is a 7 and E is an at the rate. First you need to check this logic which I checked. Is the first place here and the third place here same? If not, then this will not be the logic. Let's say, we'll do that in the questions to come. I was trying to form another question, but we'll do that in the questions to come. So we have to do remain. I have R as 8, so the first letter should be 8, and I can simply mark the option D. I don't need to solve it further. In a certain code language, 289 means read from paper. Now remember, I was about to give you a question in the previous slide. This is that question. 276 means T from field and 85 means wallpaper. Now here I cannot say that 2 is for read. What I'll have to do is I'll take this first phrase read from paper and the second phrase here T from field. In both these phrases I have this word from, which is common. So from is common. Now I'll see from the two codes 276 and 289 which number is coming to be common. I have a 2 common here. 7, 6, 8 and 9 are different from each other. So I can say that from is 2. Now I don't know what logic it is. The second word here is represented by the first number here. So we don't really know the logic. Now what I'll do is I'll take this second phrase T from field and wallpaper. Now there is nothing common in between, so this will give me no result. Let's take the first one, read from paper and wallpaper. I have a paper common here, paper and paper. Now I'll see in their codes which number is common. I have 85 here, 8 and 5, and 289 here, 2, 8 and 9. So I find that this 8 is common. So now I can say that paper is coded as 8. Now we want the code for read. Out of this 289, I know that 2 is for paper, 2 is for from, and 8 is for paper. So definitely this remaining 9 is for read. So what is my answer option here? The answer part C. Let's look at another example on symbol coding. In a certain language, C pore means book is thick, T nare means bag is heavy, Kasi means interesting book, and De T means that bag. What should stand for that is interesting? Again, we'll apply the same logic we did apply in the previous question. Book is thick and bag is heavy. First two phrases I have only is that is common. Let me check what is common in their codes. I have C pore and T nare. I know that Ray is common. So I can simply say that is for Ray. Is coded as Ray. I look at the first phrase here and this third phrase here. Book is thick, interesting book. Book is the one which is common here. What is common in these two phrases? Kasi and Sipore. C is common. So C stands for book. So if C stands for book here, then interesting is coded as Ka. So interesting will be coded as Ka because C is taken up by the book. Now I'll just change the ink color. I have that bag, and here I have bag is heavy. So what is common in both of them? Bag. Bag is common in their codes. This code here and this code here. T is common. So bag has a code of T, and therefore that will have a code of D and E. Now what is the code that I require? That is interesting. What is the code for that? That is DE. Is Ray, and interesting is Ka. Now I don't know in what sequence should these three codes be used. Should these three symbols be used? So I'll just look at the answer options and find out an answer option in which all of them at least occur. So I have Ka, De and Re. The first option itself matches, so this is the right option. If you check any of the other options, none of the options have all these codes in one. Let's move on to the third concept of substitution. Some particular words and objects are assigned with substituted names here. So either they are coded or they are called. For example, if eye is called hand, hand is called mouth, mouth is called ear, ear is called nose, and nose is called tongue, which of the following would a person hear from? Now, we all know that we hear using our ears. But ears has been coded as what here? Ear is called a nose. So where would you hear from now? Your nose. Let's look at the second question on substitution here. Now here, what you need to carefully notice that we have the word means. For example, if blue means green, green means white, white means yellow, yellow means black, black means red, red means brown, then what is the color of milk? We know that the color of milk is white, but in this language, green means white. So what is the right option here? Green. How is this question different from the previous question? In the previous question, instead of means, we had called. So if I replace called here, if blue is called as green, green is called as white, white is called as yellow, then what is the color of milk? Then the correct answer would be yellow. But since here the word means is used, the correct answer is green. So carefully note the difference between the two questions. Let's do some practice questions. Now the first thing I want to mention here is that there are infinite number of logics that can be applied in coding and decoding. The only way to improve yourself in this topic is through practice. So you should definitely visit our website and solve other practice questions, because an examiner can be in any frame of mind while he's putting a question in the exam. You'll find out when we solve this logic. In a certain language, courageous is coded as this. Then cowardly will be coded as. Now, what I suggest is pause this video right here and try to solve this question. I'll just start solving it now. Now, what is the coding done here? I'll divide this word into two parts. This is the first part, the COURN. This is the second part. So this is the first part and this is the second part. The first part has been coded in the second part here. This part, D, P, V, S and B. If you see, C is replaced by D, O is replaced by P, U is replaced by V, R is replaced by S, and A is replaced by B. So I'm doing is +1. The second part here, GEOUS, has been put here. So I have G plus 1 H, E plus 1 F, P, O plus 1 P, U plus 1 V, and S plus 1 T. So this is the code here. It might sound simple because I've already explained, but if had you tried yourself, this is very difficult. So I divide this word into two parts. So this COWA will move to the second part. So the second part would be coded as C plus 1 D, O plus 1 P, W plus 1 X, and A plus 1 B. Then this first part will be coded in front here. R will be replaced by S, D will be replaced by E, L will be replaced by M, and Y will be replaced by Z. So what is the code here? SEMZDPXB. So this is the right option here. So let's look at the second question here. The word secondary is coded as this. Now what I see here is that secondary, the alphabets here and the alphabets here are the same. So this is a question on rearrangement. So now we just have to find out how are they rearranged. What I'll do is I'll look at SC here, the first two alphabets, and look at SC here. They haven't changed their relative positions, but their positions have changed. So I have N here, N remains same. It is in the middle here, it is in the middle here. So the first thing I know is that the position of the middle alphabet will not change, and the first two alphabets come right in front of this middle alphabet. So here A is the middle alphabet, I'll write A here, and the first two alphabets P and R come here. Now what I see is that C and O have changed their positions as well as their relative positions. So that is why I have C and O. Similarly here I and M will change their positions. M will come in front and I goes at the back. Let's check the second half now. D, A, R, Y. We see that Y moves from the last position to just next to the middle alphabet here. So here Y will move from the last to just after A, and we see that D comes right after Y. So here R will just come after Y, and these two positions in the middle A and R change their relative positions and become RA. So similarly here I and L will change their position and become L and I. So the code would be this. So now my new code is MIPRAYLI, which is the D option here. So again, reinforcing my point, the number of logics are infinite. All you can do is practice. Let's look at the last question for this video lecture. In a certain language, elephant is coded as this, then how will scooters be coded as? Now I write elephant like this. I know that E is coded as F. E plus 1 is F. L becomes N. So L plus 2 is N. Similarly, E plus 3 is H. And P plus 4 is T. H plus 5 is M. A goes to G, and this is plus 6. N goes to U, this is plus 7. And T goes to B, and this is plus 8. After Z, we again start with A. So in a roundabout manner. It took me a lot of time to actually come up with this logic. It is not very simple. It might sound simple because I am explaining you, but when you start deciphering it on your own, it might take a lot of time. So what we have to recode, we have to decode scooters. So S would be changed to T plus 1 here, C would be changed to E plus 2 plus 3 and so on. So this is my code. And what is the correct option here? I think yes, this one. No, this one, the C part. So that is all on the lecture of coding and decoding. I hope you enjoyed the lecture and do practice this topic.